Okay, thus far we have looked at measures of spread, measures of center, and one particular plot called a box plot. Now before we go on to look at various other plots, we need to stop and back up and talk about different kinds of data because different plots will use different kinds of data. This is section 1.3 in your book, so we're jumping back to the first chapter, but pages 15 and 16 in your note-taking guide. So the first classification of data is whether we have names or labels or whether we have numbers. So if we are interested in data that consists of names or labels, your book will refer to this a number of different ways. I will use mainly the term categorical. Right, so categories. Your book also uses the term qualitative and sometimes uses the term nominal. So when you think about nominal, think about a name or a label. I will use mainly categorical. So examples of names or labels, these would be things that are not numbers. So for example, gender. Right, so gender is a category, male or female. It's not a number, 5, 6, 7. Your gender wouldn't be 4. Another example might be eye color. Another example might be a letter grade, whether you received an A, B, C, D, or an F. Another category might be brand of deodorant. Okay, so for all of these classifications, the data that we're collecting is going to be some sort of label, name, category, but what's important here is that it's not a number. So in comparison, we have data that consists of numbers, which represent some sort of measurement. Okay, so if we have numbers, this is what we're going to call quantitative data. All right, and this is sometimes referred to as numerical. All right, so for quantitative data, the measurement that we are pulling is going to be a number. So you can think about GPA. GPA is a number, whereas letter grade was a category. Another example is length. All right, when you measure something, you're finding a number. The temperature, or perhaps a price. All of these are going to be numeric quantities or quantitative. So our second classification is going to be for quantitative data. All right, so if I know I'm now in the category of quantitative, so let me write that here at the top. All right, so I know I'm a number. Well, we have different kinds of number. Number that represents a possible countable value is going to be what we call discrete. All right, so if we have a countable number of outcomes, so we think here the number of blank, really, the number of children. All right, I can count how many children someone has. 1, 2, 3, 4, 0. Another example might be the number of parking tickets. Again, we can count this 0, 1, 2, 3, 4. Another example might be the number of pets I have. Again, there's a countable number of options. I think this will be more clear when we look at continuous data. We'll come back to discrete. Students oftentimes want to generalize this and say, well, it has to be a whole number. Well, that'll work about 95% of the time. If it's a whole number, it's discrete because I can count how many. But let me give you an example. Shoe size. All right, shoe size would be discrete because I can count the number of possible shoe sizes. 7, 8, 8.5, 9, 10, 13.5, and so forth. I can count the number of options, but for this particular example, shoe size, it does make sense to have a 7.5. So it's not necessarily a whole number here. But that generalization will work for you most of the time. All right. This discrete data is in contrast to continuous. All right, so continuous data results from infinitely many possible values. So here what's important is that there are infinitely many possible values and that this covers some range without gaps. So an example of continuous might be time. All right, so when you think about time, it could be 1.0001 seconds. All right, well, I could also have 1.00001 seconds. I could have 1.0025 seconds. All right, and so if I'm thinking about time here, do you see that there are an infinite number of times, or there's no gaps here? So this would be continuous. Another example might be weight. All right, if you just think about between 5 pounds and 6 pounds, well, there's an infinite number of values between 5 pounds and 6 pounds. I could have 5.01, 5.01784.2, and so forth. So there's an infinite number of weights in that range. Another one might be age. So although we generally round to the nearest year, I could be hypothetically 32.87 years old. Again, discrete here, there's going to be a countable number of options. So I can count how many parking tickets I get. Whereas I could not count all of the possible times. There are an infinite number of times here. Continuous, there are no gaps here in the possibilities for weight. Whereas there are gaps here for shoe size, right? I jump from 7.5 to 8. You wouldn't say my shoe size is a 7.683. Once we know we're quantitative, we're a number, right? We can break that down further into discrete versus continuous. All right, our next classification of data is also for quantitative. So just as before, I know that I have a number here. Well, we have there's more than two, but we're going to look at two kinds. One where I have a single numeric measurement, and then one where I have two numeric measurements. So if I have a single numeric measurement, this is going to be what we're calling univariate. All right, so here uni meaning one, okay? And if we have two numeric measurements, that's what we're going to call bivariate. And here the prefix bi here is going to represent 2. So univariate, for each observation I'm going to take one measurement. So for example, income. I ask each person how much money they make each year. Well, I'm only pulling a single measurement, income. All right, another one might be the speed limit. So each section of road, each observation, I'm going to pull one number, the speed limit. Another one might be the number of toes. All right, so for each student in the class, we record how many toes she or he may have. All right, so I'm getting one number from each measurement. So if we are bivariate data, we're going to have two measurements. So let's say from each person, I record their height and their weight. Okay, so here each observation, each person is giving me two numbers, a height number and a weight number. So this would be bivariate. All right, let's say I looked at the number of hours studied and someone's grade. So from each person I'm getting two numbers. One number representing the number of hours studied and one number representing their grade on a test. Another one I might look at is income and home value. All right, again, so for each person, I'm going to record how much money he or she makes and then the value of his or her home. So this would be bivariate when each observation, each person, or each thing being measured, we're taking two measurements. Okay, and our last classification could either be categorical or quantitative. So this would apply to both. This could be for categorical or quantitative. All right, and this is whether we have one population or two populations. So if we have a single group, all right, this is going to be a one population sample. All right, whereas if we have two groups, this is going to be a two population sample. All right, so maybe if I look at any of the things we just collected, it could be one population. So let's come down here, one pop versus two pop. So let's say I have categorical data. I could look at eye color. All right, so if this was one population, I look at eye color for everyone, but if this is two population, I might look at eye color for the males versus females. Similarly, we could have univariate data. Let's say I look at height. Well, I could have one group where I look at it for all, but then maybe I have, so perhaps I have height for sophomores versus freshmen. Right? Or I could have some sort of bivariate data where I collect income and number of children. All right, so I could do this for everyone, or I might divide this into two groups, income and number of children for Republicans versus Democrats. One or two population can be used for either quantitative or categorical data. So our first classification is going to be whether we are categorical or quantitative. All right, and to determine this, you might ask yourself, is this a number? All right, so if no, we're categorical, and if yes, we are quantitative. All right, then once we're quantitative, we can break this down further into univariate and bivariate. Okay, so the question we might hear is, how many numbers? All right, so if we just have one numeric measurement from each observation, I'm univariate, but if we have two, I am bivariate. Right? Then if we, for both of these categories, we can break this down further to discrete versus continuous. All right, so the question we might ask here is, can we count our options? All right, so if we can count the number of options, then here, yes, then we are discrete. If no, there are an infinite number of options, then we are continuous. All right, or we can think here, there are no gaps. Whereas here, for discrete data, our values may jump. Right now, for bivariate, it's not going to be so clear cut, because let's say I collect two pieces of data, shoe size and height. Well, maybe shoe size might be discrete here, and then height might be continuous. So for bivariate data, each measurement is either discrete or continuous. All right, and our last classification was one population versus two, and this could apply to categorical data, or this could apply to my quantitative data. So hopefully this little graphic organizer will kind of help you when we're classifying data, because later on, dependent on which type of data we have, will help us determine which sort of plot would best represent our data. So let's look at some examples here. We want to classify each type of data. So in this first example, we have the number of siblings each student has. All right, so the first question I'm going to ask myself is this categorical or quantitative? All right, so a number here, that tells me that this is going to be quantitative. So next I'm going to say, well, is this univariate or bivariate? Well, am I collecting one number or two numbers? Well, this is just a single number, the number of siblings. So this is going to be univariate. Now I can go further. Is this discrete or continuous? Well, for the number of siblings, there's going to be gaps. I could have one sibling or two siblings or three siblings. It would not make sense for me to have 3.58 siblings. So this is going to be discrete. And lastly, one population or two population. Well, each student, we're clumping all our students together here. So I'm going to go with one population. So next we want students' favorite ACC team. The first question I'm going to ask myself is this going to be a number or a category? Well, an ACC team, that's not a number, so this is going to be categorical. Now, if you remember back to our graphic organizer, let's flip back over there. All right, if I know I'm categorical, well, there's no sense in asking questions like univariate versus bivariate because we don't have a number, or discrete versus continuous because we don't have a number. So now we only need to ask ourselves, do we have one population or two populations? So I know I'm categorical. Well, students, we're clumping all students together here, so this is going to be one population. So next, each student's gender and height. Now this is a tough one because gender here is a category, male or female, whereas height here is a number. Let's flip back to our graphic organizer. Am I categorical or quantitative? Well, here we're going to treat gender as a group. So let's think of it like this. I collect the height for my men and the height for my women. Well, that would be quantitative, but I have two groups. So let's think of this as quantitative. All right, how many numbers am I collecting? Well, just one, so this is univariate. Is this continuous or discrete? Well, height would be continuous because they're an infinite number of heights. And now this gender piece, we're going to think of this as a two population example. So I have the heights for my women and the heights for my men. So that one was a little tougher because just looking at it as is, you want to think, well, this is categorical, whereas height here is going to be quantitative. But we're going to use gender, this category here, to separate into two populations, male and female. So next we have each student's height and shoe size. This is another one that's not as straightforward. Well, height is a number, shoe size is a number, so I know I am quantitative. Right? I'm collecting two numbers, so I am bivariate. Now this is the one where we said it's not so straightforward because height is continuous, whereas shoe size is discrete. So it's not as straightforward here with this bivariate data, but we do know that this is one population. So whether or not a student is an only child. So whether or not, this is going to be categorical data because my answer is going to be yes, no, not 1, 2, 3, 8, 12, 6.5. So this is categorical data. And again, if I'm categorical, I only need to worry about one population versus two, and we're putting students all together, so this is going to be one population. So next we have the GPAs of both sophomores and freshmen. Here we have two groups, sophomores and freshmen, so this is going to tell me that we're going to be two population. GPA here is a number, so this is quantitative. I'm getting one GPA from each student. Now, even though there are two groups of students, each individual observation, each student is just giving me one GPA, so this is univariate. Let's pause here and make a distinction because students often want to tell me that this is bivariate because they see two groups. So the two groups are going to tell me that I have two different populations. So the question you need to ask yourself is each observation, each person, each thing being measured, is it giving you two numbers or one? So each student, even though I have two groups of students, is giving me only one GPA. So this is univariate. So GPA is continuous because there are an infinite number of GPAs one could have. And we have already decided that we have two groups or two populations. So we're going to use these classifications later to help us determine which graph is appropriate.